Okay, 3.6c, our last video for chapter 3.6, also last video for chapter 3. Talks about writing a linear model given a fixed value and a rate of change. So if I give you a point and a slope, can we create a line? Well, that's kind of the black stuff is from the black line would be a description of Math 41 application. Math 141 application would be the red stuff. If I give you, kind of why are we doing this? Write a linear model given a fixed value and a rate of change. So let's go forward to, let's see where we're at. And so we're going to talk about poster sales. There it is. A stack of posters to advertise a production by the theater department costs $19.95 plus $1.50 per poster at the printer. So write a linear equation. Question number 1 says, let's see what color I got, red. Write a linear equation to compute the cost C of buying X posters. All right, well, you know what? Let's set up kind of a graph here and see what it might look like in terms of our graph. Posters, so we got posters can go here or posters can go here on the y-axis. Another way to look at it might be cost can go here on the y-axis or cost can go here on the x-axis. I would say put posters on the x-axis because, again, if we're talking about what goes on the x-axis, it's things that step regularly. Number of units you produce, number of miles you go, number of hours you work, number of posters that you create. So let's go down here and put posters down here. And dollars would go over here. So anytime you have cost usually goes over here on the y-axis. So let's put cost over here. We got posters down here. This will be our x-axis. This will be our y-axis. And oh, by the way, we're going to redefine kind of our x and y. X posters would be good, but cost C, let's put cost C instead of y, because that's how they're asking us to do it. So instead of calling it y, we're going to call this axis C. All right, so let's go from there, and we'll say, well, let's see. Stack of posters advertised production at the theater department costs $19.95 plus $1.50 per poster. Okay, well, how do we put that information onto our chart here? Well, you know what? If we assume that we've got, if we walk in the the poster printer, and we say, I'd like to make some posters, they would say, all right, well, it's going to cost $19.95 to just set up our poster, and that's kind of the walk-in fee to kind of talk to us and kind of set it up. So, how many posters have you made? We've made 0 posters in terms of X posters and C cost. We've had 0 posters and how much cost? $19.95 just to walk in the store and kind of grab a business card and set it up. All right, so we can get that point and we can say, well, at 0, we're going to go up here to, and I'm going to make it not quantitative right up here, but just qualitative. So right up about here, that's our $19.95 cost. So that point would be 0, comma, 19.95 at the level of 19.95 on our C-axis. All right, so there's our first point because we need to have some points to kind of work with. Let's see, it's $1.50 per poster at the printer. So that's, we kind of used this information already. So now we've got $1.50 per poster at the printer. So if we go, let's see, if we're talking about maybe we're talking about stepping one poster forward, what's the additional cost here? So we're going to go 1 poster forward, and we're going to go $1.50 extra, 1.50 extra. So that would mean that at a point, we can get that new point there. In fact, let me change the color, and I'll say that, you know what, there's my new point. What's my new point right there? Well, it should be 1, comma, 1995 plus 1.5, and that would be $20, $21.45. So there, we can start now with 2 different points because right there is there going to be, we can create another, we can create a line using this information right there. So you know what? There's our line. So we need to, though, write a linear equation. So we can use this point. We got that point in green. We got that point in red. And we could say, let's use the slope formula to get a slope. Let's use the point slope form to create the line, but we might not need to. We can maybe take a shortcut and say, well, let's see, we know that this point here is 0, 19.95. So if that's true, then this is also 0, b. That's our y-intercept. So we could say that, for question A, we could say that y equals mx plus b. That's what we're kind of looking for. Y equals, what's our m? What's our slope? Slope is the rate of change. So if we look here, it would be rise over run, wouldn't it? So what's our rise here over the run? The rise would be the same distance here, 1.50, 1.50 or 1.5 for a run of 1. The run of 1 means 1 additional poster. So our slope should be 1.5, 1.5 divided by 1. So 1.5 should be our slope, x, plus, what's our b? B point was gathered from this information here, 19.95. So let's kind of take a look at that. So that seems to be valid because we pulled the information for slope from this rate of change here, $1.5 more for every one poster that we have. All right, so that's our rate of change, and that's our slope. And the b was just simply our y-intercept. And if we don't want to use, and we can't use this information, if we don't have this information at, the walk-in price of 0 posters at $19.95, and we get 2 other points, we would just simply use the 2 other points to create a slope, and then the slope-intercept form, the point-slope form to create the equation for that line. But because we had this information right here, that allowed us to kind of jump forward. All right, so there's our that's our linear equation that represents it. And let's take a look at this and say, well, if x is 0, if x is 0, we've created basically zero posters, then this term goes away, and all of a sudden we're just left with 1995, which is kind of the walk-in price of 1995, where you walk in and say, I'd like to set up the poster printing. So that seems to make sense. All right, so let's go to question B. Question B says, use the equation to compute the cost of 125 posters. Well, what does 125 posters means? That x equals 125, correct? Because x is the number of posters, x is 125. All right, well, that means we simply just evaluate y equals 1.5x, this equation here, for 125. So now we've got y equals y, the cost, and in fact, it probably should be c. All these y's should be c's if we're being consistent. But we can call it y. Y equals 1.5 times 125 plus 1995, 19.95. So therefore, y equals all this added up. 1.5 times 125 is 200 plus 19.95 equals 219.95. Now, this I did it in my head, so I think that's correct, but that should be our answer, 19.95 plus 15 times 225. All right, hang on one second. Okay, so I stand corrected. I actually pulled up my calculator. This should be 187. Oops, hang on a second. All right. Should be 187.5 plus 19.95 equals 207.45, and that should be the correct answer. And that should be in dollars because we got $207.45 describing the number, the price that it would cost to make 125 posters.